Hi guys, welcome back. This is day 7 out of 50 of the SAT Math Prep series. Today is our second time working on the problem solving and data analysis problem sets. So remember, these problems have to do with charts, diagrams, tables, all of that. Okay, diving into our first problem. We have a median question. So probably one of the easiest questions you're going to get on your SAT, if you do get one. 4, 10, 18, 4, 4, 5, 6, and 5. What is the median of the data set shown? So when we have these problems, we want to reorganize our numbers from least to greatest. And then 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers, so it's going to be the average of the middle two. That's always the deal when it's an even number. Easiest way to do it is just cross each side. You're left with these two in the middle, and it's always the average of these two. So the average of 5 and 5 is just 5. Let's say it was like 5 and 7. The average of that would just be 7 plus 5 divided by 2. 12 divided by 2, just 6. So just depending on what you get, be ready to handle that. Okay, moving on to the next problem. Prices of 14 different cars. Always glance at the table they give you before you go to the problem. We have types of cars priced at no more than 25 grand, price greater than 25 grand, totals. Okay. The table above shows information about 14 cars listed for sale on the auto dealership's website. If one of the cars listed for sale is selected at random, what is the probability that the car selected will be a hybrid car priced at no more than $25,000? Okay. So if one of the cars listed from so our denominator is going to be the total cars that are listed on sale. These are all listed on sale over here, so 14 is going to be our total. Now for our numerator, we need a hybrid car priced at no more than 25 grand. So looking at our column, we need to find the intersection of these two categories. So priced no more than 25 grand would be this column, and then a hybrid would be this column. And then this is the only value that meets both of those criteria. And then we simplify this fraction to 1 over 7. And this is the probability of selecting a car that is hybrid and no more than 25 grand, which is answer A. Pretty simple, again. Looking at the next problem, the International Space Station orbits Earth at an average speed of 4.76 miles per second. What is the space station's average speed in miles per hour? So we're given miles per second to begin with, and we need to convert this same quantity into miles per hour. So if you've taken chemistry already, stoichiometry, 4.76 miles for every 1 second. That's the ratio we have at the beginning, miles per second. And what we want to do is convert these seconds into hours. So we pretty much need to figure out how many seconds are in an hour. It's 3,600, but if you don't know that, this is the process of getting to that. So to cancel seconds out, since we need to get to hours, we know that in 1 minute, there are 60 seconds. These cancel out. Now we need to get rid of minute. In or 60 minutes in 1 hour. Cancel this out. And then we get our answer because we're at miles per hour. These are our units. So plugging this into the calculator, 4.76 times 60 times 60, we're going to get 17,136. And this 0.0 is just significant figures, I'm assuming. Okay, looking at the next problem. The scatter plot shows the relationship between two variables, x and y. A line of best fit for the data is also shown. Which of the following is closest to the difference between the y-coordinate of the data point with x equals 1 and the y value predicted by the line of best fit at x equals 1? So we have y-coordinate of data point minus y value predicted. So the line of best fit is the predicted. For all these values, this is the line of best fit. So we have first our actual value at x equals 1, which is 12. It's this point over here. So we have 12 minus the value predicted by the line of best fit at x equals 1, which is 11. And this is just 1, simply. That's our answer. We're getting very easy problems today. Hopefully this is the same luck you guys have on test day in August. Okay, looking at this last problem, the population density of Iceland in people per square kilometer of land area increased from 2.5 in 1990 to 3.3 in 2014. During this time period, the land area of Iceland was 100,250 square kilometers. By how many people did Iceland's population increase from 1990 to 2014? So we're looking for the increase, the increase in population. So we know that, so we have the population density and the land area. And we know population density is equal to total population over total land area. And to solve for the total population, we need to multiply population density by total land area. And really, it's asking for the increase, so it's just going to be the change in total population is equal to the change in population density. This is delta, which just signifies change, the triangle. And total land area, we don't take the delta of that because land area remains constant in this situation. So the change in total population is equal to the change in population density, which is 3.3 minus 2.5, always new minus old. And now total land area remains constant, 100,250. And then this is equal to 0.8 times 100,250. And now plug that into your calculator. And we get 80,200, which is answer D. So not a hard problem, but just really need to focus on the setup. And from there, it's just plugging in the values already given. Okay, I hope these problems helped you today, and if they did, please consider subscribing to the channel. And if you join me on the next episode, we're going to be working through more geometry and trigonometry questions. And yeah, I'll see you guys then.